Welcome to our webinar today. On behalf of NIOSH-supported education and research centers throughout the country, we're pleased to present the 2019 Ergonomics webinar series, offering free monthly webinars on various topics on human factors and ergonomics. This collaborative effort on behalf of each ERC's continuing education program aspires to provide access to current research supported through NIOSH ERC programs. Thank you so much for joining us today. Our first webinar, Analysis of Work Tasks from a Cognitive Ergonomics Perspective, Concepts, Models, and Methods, is brought to you by Rutgers University and Dr. Katya M. Costa-Black. A few housekeeping items first. You'll be muted during this presentation. If you would like to ask a question, please enter it into the online chat or Q&A. We'll save time at the end of the presentation to address questions. This webinar will be recorded and archived for viewing on COEH Northern California's website, Facebook, and YouTube channel. At this time, I'm pleased to welcome our presenter, Dr. Katya M. Costa-Black. She earned her PhD in Industrial Engineering at Polytechnic School in Montreal, Canada in 2008. Currently, Dr. Costa-Black is an adjunct professor at NYU, graduate program of ergonomics and biomechanics, and a consultant in ergonomics at BSI EHS Services and Solutions. She has more than 18 years international experience in the field of occupational rehabilitation, injury prevention, and ergonomics. Thank you so much for joining us today.
Thank you, Michelle, for this introduction. I also would like to thank the Center of Occupational and Environmental Health at UC Berkeley for this opportunity to present this very first NIOSH, very first in the year, the NIOSH ERC Ergonomics webinar series. And it's a pleasure to present the topic that really deserves a lot of more attention by all of us involved in occupational health and safety practice and research. Just a second. It is well known among ergonomists the underutilization of methods such as cognitive work analysis. And for this webinar, my main goal is to bring a general awareness of some of these methods, as well as to explain to you their underlying concepts and main models. This is not by any means an exhaustive list of methods and models, and I won't make you bored today. I try to really find and pick and choose what are the most relevant ones for this particular learning goals. And but I also will highlight some few aspects that are relevant to talk about related to cognitive ergonomics. And then it will help us to delve into the specific strategies to analyze human at work systems that are highly dependent on individual and team behavior. Cognition represents the activities and process concerned with acquisition, storage, retrieval, and processing of knowledge. And the way we process this knowledge is by a combination of brain cognitive functions of perception, memory, and thought. And I want you to keep in mind these processes are the focus point of many of our analysis or workplace analysis for cognitive demands. But we have to really go into details on understanding each of these processes and how human behavior are influenced by the surrounding environment and the technology that is used. The subfield of cognitive ergonomics is defined by the International Ergonomics Association as exactly the attention to those cognitive processes in relation to the function of a whole system. Cognitive ergonomics studies cognitions in work and operational settings in order to optimize human well-being and system performance. It brings together the subfield of cognitive system engineering with cognitive and organizational psychology, as well as computer science. It may involve studying mental workload, decision-making at team or individual settings, skill performance, human-computer interaction, human reliability, work stress, and training, as there are many other areas that can be tackled by cognitive ergonomics. And it's anything related to the human design and the human-machine behavior. We define this area of subfield of ergonomics. The overlapping of many of the topics related to ergonomics is a well-known thing that we study in the field. And what we observe is that even the application of the subfield of ergonomics should be understood as an overlapping of many aspects of data. We focus on the availability of the methods. We are a profession that is really determined by the availability of methods. So it's important to observe that if the focus of the analysis is to understand the cognitive aspects of the human system, we have methods with very different purpose. Some methods will focus on the people's data, some other methods will focus on the systems developed, and other methods will focus on the human-machine performance. So I call attention to this because when we differentiate different methodology, it gets a little complicated in terms of what kinds of focus of the analysis and what are the data that we are looking at. From a human-computer interaction perspective, cognitive ergonomics is explained by this interaction between man and machine as shown in this figure. And many human-computer interaction methods were developed with the idea that we can predict system error or optimize human-machine systems by listing the machine functions and machine operation characteristics, and then compare them with human functions and characteristics. This matching model for today's technology and complex social technical systems is not enough. What we see is that there is also today a need to pay attention to how technology, such as artificial intelligence, is pushing our boundaries on what we can and we cannot do in the workplace. And many models of the past of cognitive demands imposed by machines might not be helpful anymore because technological developments has greatly increased the complexity of job and task design, and human performance and behavioral model has to evolve as a result of these need adaptation to these new technologies. One way to keep adaptations on track is by using these essential cognitive design questions. In fact, a good method that we have is to observe and interview users with detective eyes to capture issues such as human expectations, human response, human changes in behavior when using technology. The questions are also about difficulties or ease of use of technology. Certainly it's important to observe and ask, but we also count with more sophisticated tools to test and measure the fit of the system, such as the human digital modeling, which I will discuss and talked about a little bit later. Behavioral, basically we have many of these main methods for cognitive ergonomics, which I won't be able to cover them all. And I will focus in this presentation and now on describing some cognitive task analysis mainly. And they are much more than what I can talk in a 1-hour webinar. There is today listed ergonomics literature more than 100 just of types of cognitive task analysis. I will only be able to focus on really a small amount of them, but I will give a few examples of the application that might help you to be curious about them and look more at the references that I will listed here. I will also describe briefly the other methods as we go along. Traditional task analysis might not consider the complexity of some tasks, and normally it has the following considerations. It describes the task which sounds simple, but it can serve many purposes, how and why the task is undertaken, what skills and equipment are needed, what actions are required and their complexity, the time necessary for the task, feedback mechanism, helps identify likely errors and hazards associated with the task. Now, moving beyond the traditional task analysis, then we encounter a whole category of cognitive task analysis methods. On the other hand, the cognitive task analysis methods, they are developed for complex tasks involving significant cognitive components. They are also often described as a system in terms of the goals and sub-goals, with feedback loops most often using a hierarchy approach to understand these goals. They are also flexible, and they can describe any system in any situations, in any workplace situation, whether they are complex or not. And they are versatile, and they can be used for person specification, training, requirements, error prediction, team performance assessment, and system design. The starting point of any cognitive task analysis is to determine the purpose of the analysis in relation to this cognitive system of interaction. Basically, every task requires a human cognitive function response in relation to the interface functions of a machine or artifact. And the main aims of a cognitive task analysis, it's summarized here, and I call attention to one aspect that is very important for anybody conducting a cognitive task analysis, is the idea that we have to understand the tasks and subtask elements in relation to an order and the goal of the task. And this sequence helps us to break down the tasks that are very complex and help us to really make a line of decisions that are necessary to accomplish each task. So looking to deep understanding of these subtasks, we are able to categorize tasks in terms of their complexity and in terms of the action that is required to accomplish them. And it's also important to highlight that these analyses, they bring information that are very essential to create descriptions on job requirements that were not detailed before. In relation to job design, it's really essential when new jobs are created that you have cognitive task analysis to determine the order and the precisions that are required for certain complex cognitive tasks. And the goals of these task analysis can be different goals, but the ones listed here, they describe what people do, they represent those descriptions in relation to what people do, they predict the difficulties with the task and the performance issues, they measure learnability, so it's very useful in regards to define and designing different training programs. And also, the goal of the task is one particular application would be for usability tests on particular products and particular technology. And this usability test is considered, excuse me, is considered one type of task analysis, and it's really commonly used and applied in the field of ergonomics. Each task is broken down. So when we are conducting a cognitive task analysis, each task is broken down in subtasks, and this process continues until the required level of detail is reached. It uses a variety of interview and observation strategies to capture a description of the knowledge that experts use to perform complex tasks. And it's important here to also understand that there are a level of performance that it needs to be understood very well. And when we are observing these tasks, we are trying to capture the most accurate description and trying to really capture all the aspects that are required to completion, to test completion. And sometimes the system that is observed is really an automated system, and sometimes the system needs, it will be more manual system, but in general, these observations will capture the entire process. The cognitive task analysis is often only one of the strategies used to describe the knowledge required for performance. There are many others. The outcome is most often a description of the performance objectives, equipment, conceptual knowledge, procedural knowledge, and performance standards used by experts as they perform a task. The descriptions are then used to develop expert systems, tests to certify job or task competency, and training for new or complex knowledge that is attained, needs to be attained, or for performance goals. Before the complex task is broken down into subtasks, the evaluator has to anticipate the best way he or she can learn about this behavior, the human behavior, in relation to the use of technology and use of artifacts. In any given environment, in any physical environment, in any work organization environment, this comprehension has to take place. In order to understand this behavior, we need to determine for who this analysis is for and the anticipated problems. The complexity of the analysis will depend on if we are to focus on humans as learners or as individual users or as a team. Then the problems of the technology users are registered. We try to register the success and failures of use of technology, and we try to really catalog all the information regards machine failure, human error, and interaction of humans and machines as a system. Here is an example of some different, here's a list of the analysis techniques that are being used for cognitive task analysis. And many of you probably heard about the hierarchical task analysis technique, which consists of organizing subtasks according to a system goals order. But there are many other techniques available, such as link analysis, the timeline analysis, and all ones described here. And depending on the technique selected, the detailed level of information about the task must be well specified. For instance, talking about decisions made in the execution of subtests, and we see how specific that description must be. It has to detail part of the sequencing, maybe based on a decision needed to choose the branch of activity and thus a given set of subtext. So that part of the description of the subtests are very relevant for whatever technique or methodology that you want to use. When it comes to data collection methods, so we use triangulation of data collection, trying to combine observations with interview, and sometimes we have to collect existing documentations from companies and trying to really use, when appropriate, some checklists, questionnaires, and even videotape some tasks. And here's an example that it's to describe it to you how it's being used. So the cognitive task analysis here it structures the whole procedure, a patient safety procedure in general anesthesia. And you can see that there is a need to determine time. So there is the procedure is determined by before, during, and after. And we think that the details that was necessary to be effective in describing the safety, the patient safety, is listed there. This is just one of the examples. There are many applications of cognitive task analysis, especially for healthcare It's a very well used of the cognitive task analysis. And here we have a list of other methods that are really different aspects, that bring different aspects of the analysis. And the cognitive allocation of function really focus on, really, as the name saying, to allocate functions in regards to the task and in a certain order, respecting the hierarchical way. And the critical decision method is another method that is an update and extension of the critical incident technique. It's used for different purposes, and one of that would be for companies to determine how they can make more precise decisions and avoiding error in the system. Apply cognitive work analysis. I'm going to mention just in 1 minute a few issues related to the holistic approach that is used by this type of method. So here is the purpose of the analysis is essential for cognitive task analysis, for cognitive work analysis, and for any type of these methods. But what I bring it to you is this model, this framework described by Hasmussen. And this framework pretty much shows the whole process of how to understand and focus on the entire work system. The selection of the appropriate cognitive task methods requires that we really understand that process of analysis. And the starting point can be the work tasks as indicated in this particular framework. But when it comes to cognitive work analysis, we don't stop with the assessment of work task only. We go beyond and look into social organizational, collaborations, group design, work situations, workplace culture, and trying to really look into elements that will influence the behavior of people in the organization. And you look into the components of work domain in very details in relation to the value of the people, the value of the products, the functions, the physical and non-physical aspects of the functions in the workplace, and the resources available. So it's a very holistic approach, and this is and we can say and we can determine that cognitive task analysis is one part of the analysis within this more comprehensive view of cognitive work analysis. And here is one example where a cognitive work analysis is necessary to study and look into structure of accidents. And because of cognitive task analysis would limit the understanding of the entire structure of the accidents, we focus the attention more on the analysis of the whole work situation, and here including aspects related to the mental condition of the worker, the emotional condition of the worker, the safety management performance aspects, and they're all like listed contributing causes to this, to potential having problems with the accidents. There are also lists of potential causes that are related to the directed behavior of the user of machines. So if you look into the unsafe acts, it describes that the equipment usage, how it's used, the improper tool usage, what kind of movement that can be leading to accidents. And the system gives a very general view, but it also can really be more detail oriented if you use it for each aspects of the task, a cognitive task analysis to determine the actions that are related to the process to complete the tasks. It's sometimes necessary to look into details on error analysis because they will give us information on how to reduce the possibility and the potential of error. When we can predict error, there are methods that help us to look into it, and this prediction is based on a calculation model, and it tries to look into what things can go wrong and what are the chances that they're going to go wrong. One of the methods is called the Sharper, and the other one is a very well-known in ergonomics, is the task analysis for error identification, and is based on the idea of rewritable routines. So you have it that the two forms of outputs for this particular method, it's the predicted errors from human interaction with a device, and then you have also the other form of outputs, which is the task flow model based on mapping human action into state space diagram. So in summary, we have a very large amount of methods that we can use for evaluating cognitive tasks and really trying to better understand cognitive demands. And there are many benefits for actually using this methodology. And the systems that we have, the complexity of systems that we have in place today require us to really pay attention to these methods. Some of them are very useful for enhancing efficiency and productivity in the workplace. Some of them can use to really reduce the amount of human error and looking more into the safety aspects in the workplace. And other methods are very useful because they can really increase the potential of efficiency for humans to perform tasks in a more efficient environment. And also they can really be a way to prove to companies that there is a value on improving the system, and new technology may add that value or not. And there are also important aspects to analyze when you look into the cost associated with improving the system and reducing errors and problems related to waste. There's also a very large potential of using this methodology for patient safety and in general, to reduce mental fatigue because of their focus on the cognitive aspects. And we cannot forget the social environment in this arena of understanding the tasks and then really understanding the workplace from the point of view of ergonomic system ergonomics. Is necessary that we consider the financial and the social environment and the aspects of the technology usage. Advanced technology is here to stay. This won't change anytime soon. And we have to be determined to make things better, and how our social environment really determines the acceptance of technology. And we have to consider the human behavior is really prone to social norms, management practice, culture, management styles, and might take time also for people to accept and be ready or not for the technology that is coming. And I will take questions now. I finished a bit early, and as expected. Is there any questions?
Oh, yes. If you have a question, please do feel free to enter it into the chat box or the online Q&A box. Our first question is, what would be the best cognitive task analysis method for manufacturing environment? Some of the tasks are packing, grinding, and material handling.
Yes, I appreciate this question. I think if you're looking for a quick solution, cognitive task analysis might not be what you need, but hierarchical task analysis is to break down the task, especially in manual handling. It gives a lot of information that helps you to get from understanding not just the impact of the system in the people, but also to understand the order and the waste that is can be avoided. Part of what the cognitive task analysis can do, it's also create a system that managers can look a little bit more details into the production system.
Thank you. Another question, what specific tools do you recommend for assessing mental fatigue during task analysis? NSAS, or I'm sorry, NASA, NASA, TLX, question mark?
Yes, definitely. It's a very good tool to use. There is a modified version of it. There is a shorter version. The original version is very long. Some of the methods we have to really make a reflection on how needs a bit of an improvement, but the NASA is has extremely high content validity testing done, and they had completed reliability test. Also, it's excellent and very high. So it's a trustworthy tool that should be used as much as possible. But just a caution that it takes time.
Thank you. Another question, do you design for 90% or 95% of the working population, or 99%?
Ooh, for 99 or 95%. The design issues to me are very contextual. The design for 95 percentile, it really would depend on the type of design, the question that you have. If you're talking about design of a workstation that requires a lot of more accessibility from a large group, but the recommendation in ergonomics for design is definitely 95. 99% is a very difficult achievement.
Excellent, thank you. What are the methods to communicate findings to the worker and management?
What is the way? I believe that the best way to communicate to workers would be to create this open communication from the beginning. If you're doing assessments in the workplace and you are not sure how this can be used, before you interview workers and you're talking with workers, you try to really understand better their side and how they can use whatever results of data that you will have later. If workers don't really able to understand and really use what you're gonna do, there will be very little application, and the chance that you will be able to make a change, it will be reduced. So my main thing is, please listen to the worker first and trying to really understand better who are your users, what they actually can tell you about the problems with the systems that they're using. If they are able to tell you the problems, you can find a direction on your analysis that will be really pretty much triggered by what they are presenting as problems. And I think it's more accurate for the results in the end.
Thank you. Another question, is there a relationship between cognitive abilities and age?
Yes, the cognitive neuroscientists have been talking a lot about cognitive abilities of aging populations. I don't have the accurate information of the latest neuroscience research on this. I would say that what I read and what I have understood from the readings I've done is that we start having decreased cognitive abilities at age 55. And this is something normal for the human aging part of life. And we know that cognitive abilities will be decreased starting at age 55. And for people who have cognitive disease, they would have fast deterioration of their cognitive functions. And it's important that in the workplace, whenever we are doing solutions for improving any system or use of technology, that we consider the population over 55 exactly because of this issue of the deterioration after 55 on the cognitive abilities.
This is another question that's also related to aging workers. Cognition is sensory dependent, and thinking about the aging worker, how can the various visual and hearing impairments be excluded as a confounding variabilities in cognitive task analysis?
Yes, this is an excellent question, and I don't have the answer. It's really difficult to, so to account for all of the sensory aspects and really looking to the aspects that really impact on people response to and behavior response in relation to the task. It's really, really difficult. I don't think we have enough in science yet to bring light to this question. I wish we did, and I think we have to move forward with this and try to get more people interested in this topic and doing more research.
Excellent, thank you. We also have a comment someone just wanted to also add, mentioning accrued experience with age.
Accrued experience with age. I don't have much experience with this. Is it a comment or a question?
Oh no, it was more of a comment. Just bringing into the conversation accrued experience.
Yes, no, interesting. Yeah.
Another question, do you have a recommendation for a tool to assess the safety culture organizational environment?
Yes, I can provide my email, and whoever asked that question, I could send an information on.
Great, thank you. We do have some more questions. This is wonderful. Thank you everyone for all of the questions here. Is CTA more suitable for complex jobs, or can we apply it to any kind of jobs?
Traditional task analysis can be used for any kinds of jobs. I believe that CTA are more suitable for more complex type of jobs because it's cumbersome. It takes time to complete. If you don't mind the time and the process, I would say you can go ahead and do it even if it's not complex. But there is a more simplified way of getting some information on system improvement by using traditional task analysis.
Thank you. Are there any tests or frameworks to assess the effect of organizational ergonomics on cognitive ergonomics of individuals or a group?
Yes, they are. Actually, the book that I referenced on this lecture, it has a specific group of methodology on teamwork. And that would give information on this, all elements related to cognitive leadership style and things related to organizational issues that will impact on cognitive functions and abilities.
And what do you think the big difference between cognitive task analysis and cognitive modeling methods?
Oh, well, cognitive modeling methods are really putting together specific theories that are probably tested theories that they want to define in a way that will give them the background information to develop new methods. That's my understanding. And cognitive task analysis methods are already kind of well-established framework used with very defined elements that we look in terms of the interaction in ergonomics that I discussed in my lecture. So for me, that's the main the difference. I didn't talk much about it and was missing discussing human modeling, human digital modeling, and that's a one aspect that really bring another layer of complexity, I would say, And these cognitive modelings can be very useful when you're doing simulations, when you want to do understanding the system before it's being designed, before is final decision on the design, and to test the design. They are very, very useful.
Thank you. Do you find Fitts law to be an effective tool for cognitive task analysis where precision is needed? And if so, how do you recommend it be applied for the best effectiveness?
Yeah, Fitts law is, I don't know if you can use it for the effectiveness of using, but testing effectiveness. I think what is missing in the Fitts law, it's missing a kind of a follow-up way that we can understand after you complete the analysis how you actually can get to deliver the information. I find the method kind of sits alone on the information, and it's hard to deliver. That's my take on that. I don't have a lot of experience with that particular method, and what I know is based on what I teach to my students and what I have learned on my PhD, but I don't have enough to fully answer this question.
Thank you. Do you have any specific models to predict human error? And if you do, what kinds of error can you predict?
Oh, yes. So there are so many models, and that's one part that I took away from my lecture because I found like it's so many different types. Human error, machine errors, predictions. The type of error you can do is related to any type of cognitive response related to use automated system, related to using any tool or equipment, related to accidents. There's a big list. The human predictions model that are listed in the handbook that I mentioned are good ones, and they have checklists on. There's one particular checklist on our prediction. There's a mathematical calculation also. There's a number of things that can be used. But I think there is also in the Ergonomic Society a group, a specific technical group that are working on particular on this issue. That it's, if you're really interested in the subject, I recommend you join the group. I'm actually not part of the group, and you will know a little bit more in details on this aspect.
Thank you. We have another question. Could you speculate on the future evolution of human technology interaction since technology can process information and make decisions more quickly than humans?
Mm-hmm. Yeah, I predict this question will come. I actually, this whole idea of talking about this subject came from a friend of mine trying to interfere a little bit on what I was doing and said, pause everything you're doing ergonomics. I need help with artificial intelligence. And at one point, after many discussions, and I cannot name which big company he works for, but I reflect on my career and trying to think about how can I be a scientist and looking to artificial intelligence and what are the positive aspects. I think there's a lot to come with the new technology, and we have to embrace part of it, but we have to really reflect on how this is going to restrain our environment, our social environment, our cultural, our aspects related to really socialization and emotion. There's one aspect of cognitive and perception that I didn't discuss, but it's really implicit on the whole cognitive model is the idea that we have emotive brain that creates a whole different disposition for how we behave in relation to use of technology. We have to really pay attention to that, how we are behaving ourselves with technology today, and how we can bring it a little bit more questions to the use of technology in a group setting. All these aspects needs to be still to be determined, but I think there's there is a bit of a concern from what I show a little bit on my slides on the aspects of artificial intelligence taking some jobs. People would be, losing their jobs and trying to see how this can be used in a way that won't put an overload to people who remain at work in terms of more cognitive demands and more responses to systems that are becoming more and more complex. So we have to evaluate that and trying to find a balance act there. It's not going to be easy. I don't think I have the answer, but I think there is a possibility to work side by side with technology.
Thank you. And do you feel that voice-enabled devices like Alexa and Google Assistant will be beneficial or have negative consequences on the worker?
In many ways, I think it will be beneficial to workers. Yes.
Thank you. And as far as continuing resources, are you able to point anyone in directions as where they might get some available online tools or where they might look for resources elsewhere to continue their learning?
Yes. There is a whole software system engineering website that I'm trying to see if I can get it here. I don't know on top of my head, but there's if you search for digital modeling, you find like 2 or 3 very one software called Hamasis, and there is another one that's called the CAD. And then we have a lot of other ones that can be helpful for anybody who is interested to look into more artificial intelligence. And the IBM has a new software that is interesting to look at it in terms of this technology, and there are videos about it. The other aspects that can be also looked at it, and if you Google exoskeletons, should be also part of this whole idea of using technology in the workplace. It's been really a big discussion now in many conferences that are coming up, and then they have in the past. If you look into again, the Human Factor Ergonomics Society would have a list of information specific on the projects. The Human Factor Ergonomics Society, there is a chapter for, if I'm not mistaken, for human error in human reliability, and there is also for technology use.
Excellent. Well, thank you so much for your time. We do still have a few more minutes. If anyone else wants to enter a question into the chat box or the Q&A box, I'm happy to read it aloud. And I did actually get one question that was emailed in prior to the webinar that I would like to share with you.
Mm-hmm.
Warning signs and safety posters are often relied upon by managers to influence employee behavior. In my experience, the vast majority of workers take little or no notice of such signs once they've been posted for even a short while. Are you able to comment on this and any research of which you may be aware of that can shed some light on this widespread practice?
Yes, I do have an experience with safety poster. Yes, it's really true that they are not disregarded in the workplace and not noticed. I think that you have to evaluate first the purpose of using the safety poster and how it's labeled, because sometimes, in my experience, it's also necessary that the poster should be there as just a reminder, but all the aspects of safety that is in the poster should be highlighted in every single staff meeting. If you are just putting a picture, a visual thing to, that was what we were talking about during the meeting, it helps them to see the illustration and the communication, the oral communication combined. That would be helpful to avoid this neglected view of the poster. If you just put a poster and you don't talk about it, that's a very big issue there, because you were not communicating a full way for assimilation and for processing the danger aspects of that work. So it's highlighting by talking with people in a verbal way, and then using the visual posters to give them more of the reminder points that is necessary.
Excellent. Well, thank you so much for joining us today, and thank you to our audience for these wonderful questions. This is a part of our new NIOSH-supported Education and Research Center webinar series. We'll be offering free monthly webinars on various topics in human factors and ergonomics. We're excited. Our next presentation is going to be on March 20th, from practice to policy, preventing muscular skeletal disorders and hotel room cleaners. That will be with Dr. Carissa Harris of COEH Northern California at UC Berkeley. Thank you again, everyone, for joining us. If you want to revisit this webinar, it is currently on the COEH Northern California Facebook, and it will also be available on YouTube. It will also be embedded onto our website page where you signed up for this webinar, coeh.berkeley.edu/ERC webinars. It's where you'll be able to see all of our upcoming webinars throughout the series, and we'll archive the old webinar videos there. Thank you again so much for joining us, and I hope you all have a wonderful day.